Hello everybody, it's Chris Schmidt from Rocket Lasso, and welcome to the quick start video for the Rocket Utility Splines. Now, we've been working on this one for a while. We had to shift our focus for a little bit, but we're back and this is ready to go. Now, I said quick start, but this is more of a project breakdown and some demos and use cases for what you might use these utility splines for. If you want to see the technical details and like a really nitty-gritty breakdown, make sure to check out the individual instructional videos for each of the tools. But for now, why don't we dive right on in? You will find, I'll turn Maze off, you will find these tools under your plugins or extensions dropdown, RKT Utility Splines or Rocket Utility Splines. And it's important to note that these tools are compatible with R20 and above. Having said that, let's create a Rocket Smooth. We are going to drop this camera track as a child of the Smooth, and I'll select the Smooth and drag iterations down to 0. Let's talk about what we got. Well, to begin with, I've got a camera track. Imagine you were tracking the motion of your iPhone and you bring that into Cinema somehow, and you've got really jittery information here, and your camera's gonna be bumping all over the place. Well, using the smoothing utility, I can start adding in iterations of smoothing, and that spline will parametrically become very smooth and rounded. You'll see as I rotate around here that everything is looking nice and smooth overall. Now, if I drag up these iterations more and more and more, it's going to get smoother and smoother and smoother. If we keep on going super far, it's eventually just going to turn into essentially a straight line. So you don't need to go too far with it. But as we add in these iterations, you see, yep, nice and smooth. Now, I'll make a duplicate of the camera track because I want to compare what the original line looked like and what our new smooth version looks like. And yeah, it's definitely following the same shape, but you might notice that it feels like it's shrunk down a little bit. It's not quite as big as the original. Well, we've got a setting for that, and it is counter scale. As we increase the counter scale, you see it's going to scale back up again, and it's going to start fitting that spacing a little bit more. It's important to note that getting rid of counter scale, that as we take every single little point from here, it's looking at its neighbors and averaging them out. And when you do that, everything naturally shrinks. So sometimes you're going to want to counter scale, sometimes you're not. So you can increase this back again. Typically a good idea to counter scale back to the point where it's like, well, half the lines are undershooting and half the lines are overshooting, which perfectly makes sense. If you're smoothing something out, you're getting the average. So yeah, that's looking pretty good. Now, just to push it a little bit further, it's fun to take counter scale and maybe overshoot. Like we can go way further. You can also go negative and push it the opposite way, just kind of weird and abstract, but that can be interesting. We can also, increase your smoothing even further, and you are now set up. We can hide this copy and just have this new spline that you could be having your camera traveling along and make it nice and smooth for you. So that is a super duper basic of what smooth might do for you. Let's delete that and let's take a look at Maze. So this Maze spline is, I don't know if you've ever imported like CAD information or you're getting files from Illustrator, and things can just be a mess when they come in. So in this case, let's take a look at the points, and you can see that I've made this extra bad in this case, but you might get something that's heavily subdivided with a whole bunch of redundant points. And here I went super overboard, and over here you see we got a ton of subdivisions in the corner. If you were to take the spline and feed it into something like an extrude, hit NB so we can see all the polygons. Obviously, we're getting a pretty messy spline, a lot of redundant polygons. Everything in general is going to take longer to render, longer to process. Simulations are going to look messed up. If we switch the caps to have a cap type of quads, you're going to see that this is going to be super messy as we zoom up here, tons of polygons. So what do we do to fix this? Well, why don't we pull the maze out, and I'll drop this inside of the next utility. And something that's handy is if you hold down Alt in Cinema while you're creating any object, holding down Alt and say RKT Cleanup, it's going to automatically make the thing you have selected become a child of the new object. So in this case, if I were to select this and drop it inside the extrude, you're going to see that we've got a very nice clean geometry. Cleanup is a utility that's going to get rid of every single redundant point. Every single thing that's not contributing is just going to be removed. So all these straight line points have been gotten rid of, all the ones piled up on top of each other. If there's any points directly on top of each other that are redundant, and which can also cause problems, I've run into fonts that will accidentally have points directly on top of each other. This will parametrically clean that up and get it ready for you. Now, this is a good opportunity to pull this out and show you some other functions that we have. If I were to click on this tick marks setting inside of Cleanup, I can say, hey, show me the result here. And, we need to be in object mode to see it. And if you do that, we're going to see little tick marks representing where every single one of the points are. This will become important a little bit later on, but something I want to point out right now is you can actually put this back to none so we're not seeing it. If you double click on the icon of any of the utilities, it will actually automatically activate that for you. So it turns on the result of showing tick marks. And if you double click again, it'll turn it off. Very useful for quickly turning that on and turning it off again. Let's move on to the next demo file. Okay, super important detail here. I'm going to be using an unrelated plugin for part of this. We're going to be using Ricochet, also from Rocket Lasso, in order to fill up this geometry with a bunch of bouncing laser lines. So just throwing that out there. So I've got this text object, and I've got a pretty low poly. I'll feed that into a remesh to get nice, even distribution. I'll feed that into a connect just to have it all be welded and nice and clean. And that's going to have a collider body on it. This is going to be using the new simulation system, the rope system that's in R26 and above. So I want to fill this up with a bunch of lasers because eventually I want to make this look like it's filled up with a bunch of ramen noodles. Going to extensions, grabbing the different plugin, Rocket Ricochet. I would like to drag it, let's say a little bit inside this letter X. And inside of the Ricochet, I'll say, hey, link to that text object. And if I were to hide the text object, you now see I've got this line bouncing around inside of it. If I start increasing the length, you see that this laser is going to bounce and bounce and bounce and bounce and bounce and fill up that overall shape. So let's bring this back in and I'll hide the source. So you can see how that's bouncing around. I want to fill up every letter, obviously. So an easy way to do that with a Ricochet is click Create Matrix. And now it's created a matrix object that's creating little matrix objects through all the text. So if I select that matrix and start creating more copies, eventually I should get some that are filling up every different letter. I'll find a good random seed where they look like they are somewhat evenly all filled up together. There we go. I'm going to want to run the rope simulation on here, but the rope simulation wants everything to be very evenly subdivided. So let's go about doing that. And let's make sure the length here is looking pretty good. Is that filled up enough? Yeah, I think that's looking pretty good. So I will zoom up pretty far in a straight line. This should work pretty well. And right now it's not going to be overly subdivided. So what if I feed our Ricochet into a resample? So hold down Alt and it'll put Ricochet in as a child. And now the resample, double clicking on the resample, we can now see our subdivisions and I can make this as even and as subdivided as I want it to be. In this case, we're saying step of 5. What if we say a step of 3? That seems a little bit better for running a simulation on this. That should be filling up the space pretty well. Having done that, how about we add now a simulation rope? So now there's a rope tag on there. I'm just going to change 2 things. Let's get rid of all the friction so it can freely slide around. And the radius I'll increase up to 1. I just know that that's the radius I'm going to want here. Having done that, let me hit play. And now, hopefully, we've got some very, yeah, look at that. We've got very evenly subdivided spline. It can quickly and uniformly simulate all of the different splines we've got here. Having done that, let me hit pause. We can drop this in to the weighting sweep for the spaghetti and take a look at it. And let me deselect, and you can see that there we go. We've got spaghetti not intersecting itself and instantly subdivided it to the exact amount that we wanted. But if we zoom up, we've probably got some additional problems here. Let me hit NV and we can see all the polygons. You can see, yes, it's working pretty well, but we get some really sharp corners here. Even angles like this are pretty sharp. So we could subdivide this way more, but the simulation is going to take longer to run. Probably don't want that. We definitely don't want these sharp corners shooting out. So what if we then take this resampled spline, this resampled Ricochet, and had a simulation run on it, and we feed that into a smooth. Keep in mind, which is something that's really awesome, is that the rope simulation is treated like a modifier. This is not changing the original geometry. This is modifying at this level, meaning we can now, as a post effect, run a smooth. So keeping this completely parametric, not baking anything, I can feed this resample into a utility Rocket Smooth and start smoothing these out. Couple things we want to do though, like yes, that's now rounded this out. We've added a bunch of iterations of smoothing after the simulation happened, which is cool. But if we just start adding if we add in iterations here, then it's going to lose the fidelity and the positioning of these. Like maybe some of these will start passing through each other because, yeah, like maybe right here, it's starting to pass through each other because there just wasn't enough resolution and we're, again, kind of shrinking down. Now we can fix that a little bit by counter scaling, which might push those back out again. And that's working great, but something I have found that works really well, and just to show you, let's get rid of everything that's happening right now. Let's subdivide this. Something that we did is, even though we have a resample tool, we thought it'd be helpful when you're using Smooth to be able to instantly resample things. So currently it's just taking the baked line. It's taking exactly what the points looked like that was fed in, and that's what it's working from. But we could say, actually, your point input will be based on a step, in which case we could resample the incoming line. I could resample that down to 2, we could resample it down to 1, and I can see it's way more subdivided. But instead of that, I'm going to say don't do it via step. I'm going to say do it via subdividing. I'm going to subdivide, in this case, once. And now that we've subdivided once, let me put that back down to 0 so you can see the difference. You see very low poly. Let's subdivide it by 1, and now we've got extra geometry. But I already know we're going to want more, so I'll put this up to subdivision 2, which is going to, essentially we doubled it, and we doubled it again. So now you can really visually see these sharp edges. But what's great about this is now that we've added extra geometry, as I add in a couple of iterations of smoothing, that line is not getting pulled in and intersecting the other line because there's extra points for it to deal with. So now we get these lovely rounded corners and everything looks very even and smooth, but this didn't have to run before the simulation. The simulation doesn't take any longer to run. We're now subdividing and then smoothing after the fact. So yeah, look at that, looking great. If we wanted to, I could try and do some counter scale, but honestly, I don't think that's strictly necessary. We're pulling back so little that those intersections are not gonna bother me. So awesome, we've subdivided. That's looking way smoother than it would have otherwise. But let's keep in mind that we've now created a whole bunch more geometry. In fact, our utility splines can inform you of how much the geometry has changed. If I select the smooth, we have now subdivided twice. If I click on advanced, we can see that originally there was about 20,000 points that came into this, but now we're closer to 80,000 points. We're at 400%, which makes sense. Like I said, we doubled and then doubled again. So that means the sweep is going to have to work all the harder to sweep all these extra points. But we can feed this into another tool. We could resample it again, and that would actually work all right, but we can use a different tool entirely. And in this case, that is going to be the RKT Reduction. Again, holding down Alt will feed the sweep into the reduction, and instantly see that, well, there's way fewer polygons, probably way too many fewer. So let's go to the main tab of the reduction. Right now we're in deviation, but you'll see there's 4 different reduction modes, each with completely different algorithms. But I love deviation, and what this one is doing is it's saying, as long as a point isn't more than 1 unit away, we can get rid of it. But essentially, we want to add more detail here. This is pulling away too much. So we just start reducing that tolerance. I'll drop this down to 0.1, and you'll see a whole bunch of points come back. But not all of them. You'll see that in these sharp corners that we still got plenty of detail, but these straight long areas, that didn't need as many polygons, where visually we're not going to be able to tell, and it got rid of those. So, and we can push this even further, let's say 0.05 to, actually 0.05 will bring more back. So you got to find like the balance number of exactly where this should be to reduce as many as you need to. Let me hit NA and zoom out a bit, and you're going to see that like I'm having trouble seeing the polygons missing, but let's go all the way to 1. Clearly that's too much. Let's go to 0.01. Now we've pretty much pulled them all back, and B, you're gonna see lots and lots of them are still here. Some have been gotten rid of, but not too many. Back to NA, if I keep on increasing this number, at what point do I actually see the difference? And I'm thinking 0.05 is a good number here, where if I go back to a tolerance of 0, that means everything is here. And if I go to 0.05, it's gotten rid of a whole bunch of them, but I don't see a difference. So let's hit NB again and take a look. And it's like, yeah, a whole bunch of these have gone away. Look how straight this section is, and therefore there's very few subdivisions. Meanwhile, our curves have lots of detail. Back into the Advanced tab, I can see that we went from almost 80,000 to under 30,000. So we've gotten rid of, at this point, we've gotten rid of like 65% of all the points that were there. They were gotten rid of, and visually they'd be almost impossible to see. So having said all that, let's go and zoom out again and hit play, and you'll see that we are able to run that smoothing and that reduction after the simulation, not increasing our simulation time, but making these look way better. Once again, just for showing it, if I grab this resample and pull it, here's the actual simulation, put it directly into the spaghetti, you're going to see that we get these super sharp edges back, like shooting out into the middle of nowhere. Put it into the smooth and then the reduction, and they get nice and clean and rounded. So I think that this combination of tools goes a really long way for creating a rig like this, and I find myself using it constantly. If you have watched any of the Rocket Lasso live streams, I was constantly reaching for the utility splines, which I always tried to avoid because they weren't live yet to everybody for other people to use. But in any case, let's move on to our next demo. In this demo, we are going to look at creating almost like a stop motion-y look on top of a spline. But we can do a couple different things first. First of all, we got the basic default font that Cinema uses. And let's say it's a good looking font and we want to use it, but what if we want to round these corners out a little bit? Well, we can do that with utility splines as well. With our text spline selected, I will go to Extensions, Utility Splines, hold down Alt as I create a RKT Smooth. Okay, let's slow down for a second. Why does it suddenly look so different? Well, let's step through because this is important. Selecting the Smooth, I'll say 0 iterations. So essentially we're seeing the original spline unmodified. If I were to turn on our tick marks, or even better, double click on the icon so we can see exactly where the tick marks are, exactly where all the points are, and we zoom up, you're going to see that every default spline in Cinema is set to, let me select it, it is set to the adaptive mode, saying create a new point every time a spline moves more than 5 degrees off the previous one. Now, typically this is great because it's only adding in detail exactly where you need it. These straight edges don't need any subdivisions. Those would be redundant. They're not doing anything. But in this case, you see that we get all this detail in the curve and none in these straight areas. Now, if we start adding in iterations of smoothing, there are just no points to sample there. So areas that were very flat and very smooth suddenly move dramatically, and areas that are very subdivided, well, those barely move at all because there's so many points for it to sample an average between. So in this case, something that's pretty handy is we can go to our point input and change it from the baked line, meaning whatever is incoming from the spline naturally. And I can say, actually, do a step resampling here. And you'll see now that we are creating a subdivision every 5 units, which makes this very evenly subdivided. Meaning, grabbing my iterations and increasing, we can start making this text look very cartoony and very curved, entirely parametrically, which is pretty fun. We change this to any font we want, all parametric, ready to go. Nice, cool, cartoony looking font. Let's zoom back up again and just play with the iterations. We go really far. We could just barely go. So yeah, that's looking pretty cool. And if that's what you want for your font, then hey, you're ready to go. But let's say that you want to round it out just a little bit, just to have a little almost like bevel on the corner, but keeping everything organic. Well, if I were to drop this to 0 and say just do 1 iteration, well, this is a relatively large curve still, and that's pretty sharp right there. It just doesn't have the resolution to make something that is smoothed out in a small area. Instead, we've got a resolution that's calling for kind of a large curve. So instead, why don't I change my step to something sharper, like a step of 2? So get rid of the iterations. You see way more subdivisions. And now as I increase my iterations, we get more resolution in a smaller corner. Dropping that to a step of 1, you now see we got lots of points to work from. And as I add in iterations, most things are they're not moving or barely moving at all, but these corners will move just a little bit. And now we get this it's sharp, but a smooth corner. So a very nice rounded corner. Zooming out, you can see we took off those sharp edges of everything, but we still are maintaining that original font really well. That's working great. But if we were to feed that into the extrude, it's like, okay, that's looking fine. But if I hit NB, you're going to see that we actually have a lot of subdivisions. These are a lot of polygons to be extruding, and we don't need it to take that long to calculate. We don't need to be generating extra geometry that we don't need. So this can actually combine really well with other tools. I'll pull this out from the extrude, and let's hide that. And what I'd like to do is feed this smooth into a reduction. So feeding this into reduction, holding down Alt, it's going to default to deviation, and it's probably the best mode to be in. And you'll see right now, if we put that back into the extrude, you see that we've really reduced the count of them. We're like on this edge of the P, it's gotten really, really flat. Again, no subdivisions. But let's pull this out and double click and take a look. But we can change this again by changing our tolerance. If I say, hey, I want to keep everything, if it deviates any more than 0.1, you can see that we've brought back lots of the curvature on these rounded areas, but these flat areas got rid of all of those extra redundant points. So feeding that into the extrude, you can now see we got the best of both worlds where you get that nice, clean, rounded edge, but the straight areas did not require any additional points, and we've got a nice rounded spline. So very pleased with that. It's a good combination. of using the smooth and the reduction, but let's stay in the scene file and do something completely different. Let's say we want to do more of a stop motion look here. What I'm thinking is let's pull the spline out. We don't need any of those anymore. Let's feed this text spline directly into a resample. So here's the Rocket Resample. And by default, you see it's set to step. So we're just resampling every, let me double click on the icon. You see we're resampling every 5 units, but we got a couple different modes here. There's step mode, but we can also set it to count mode. If I click on that, it's now making so that every single one of these splines has exactly 100 points. Now, in this case, that's not super useful, but let's say you're morphing one spline into the shape of another spline, that could be useful. Instead of a point count though, we can also subdivide, which we've already seen, where right now with 0 subdivisions, we get just points in the corner. That's actually all looking pretty neat with this almost like low poly look. But we could start increasing this and say, hey, there's 1 point in between. Subdivide again. And now we got a point in between each of those points. We can keep on going further and further and further there, creating subdivisions. What I'd like to do is change point input to random step. What random step is going to do is walk along the spline and create a new point anywhere from 0 units away up to 10 units away. Let's exaggerate this a bit. I'm going to say anywhere between 5 and 55. So some quite large leaps in between them. So you can see different random distances between each of those points. But you can see that we get kind of a fun little low poly look here. I know it's a spline, but kind of low poly looking. But we can push this even further. If I go and twirl down this min and max, you can see we've got some additional settings. We've got a random seed, and you can click this little random button we've got to randomize the seed and have it jump around. You see there that that's kind of a fun jittery look on top of it and entirely parametric. But let's push this even further. We can automatically animate the seed with this animate parameter. If I set this to every 20 frames and hit play, you're going to see that every 20th frame, it's going to generate a new seed for you. If we put this on 1, we're going to get something super jittery where it's jumping around all over the place. I think a nice stop motion look would be, 2 or 3. I'm going to go to 5 just so we can see everything nice and clearly and see that this is jumping around every 5th frame. So that's working pretty well. What I would like to do is probably round this out now. We've got a nice animated random spline. So let's feed that resampled spline into a extension, utility spline, smooth. And if I just smooth right now, you see the same problem. There's not very many points, so it's going to kind of obliterate the look. So let's subdivide the previous result. So I can say, hey, do a step subdivision. And now we end up with, and let's even get rid of the iterations. You can see that if I double click on there, that we get those kind of sharp edges going, but the points are subdividing more. And as we add in smoothing iterations, we can take these sharp edges off, round them out a bit, and now we're left with a nice stop motion-y look. Dropping that into the extrude, you now see that we've got a little stop motion spline jittering around without very much work. All we have to do is set our min, our max, set the animation frame, and then smooth it out with a smooth. And that can be fed into any spline anywhere in Cinema, including even like a simulated spline. So that is one demo file. The end result of this is actually included with the demo files that come with your purchase of the utility splines. But let's move on to the next demo. And it's going to get a little bit fancy. And again, important detail, I'm going to be using another unrelated Rocket Lasso plugin. We're going to be using Slicer just one time in here, but it's going to combine with a whole bunch of different utility splines. So what do we got to begin with? Well, I've got this text spline, and I've also got a cloner with a sphere, and that's cloning onto the spline. If I hit play, I've got some random effectors that are making these spheres drift around. So that's an important detail. These are all moving around. Let's say I want to round out my text a bit. We already know how to do that. I'll feed the text into an extensions, utility spline, smooth, holding down Alt. I would like to do a step subdivision and round these out a bit, not too much. And that should be nice and round there. That's looking pretty good. Maybe step it a little bit smaller if I want to. Drop this down to 4 and one more iteration. Excellent. Now I would like to probably reduce that. We don't need all the extra geometry here. You see if I double click, we got lots of points. So feed that into a reduction. Say reduction there. And a 0.1 tolerance, so everything stays pretty rounded here, but these extra edges, if I double click, have gotten rid of their extra points. I'll feed that into an extrude. So there we go, holding down Alt, it's fed in. There we got a nice big extrude there. Probably don't need to go so far back, so I'll say just an extrude of 10. And now we can take a look at that text and these spheres blobbing around, just kind of just passing straight through each other. What I'd like to do is feed these into a volume builder and just make one big oozy blob out of them. So creating a new volume builder, I will feed in the extrude. I will feed in the cloner, and those are all getting blobbed together, but the resolution is not so great. So I'll drop the resolution to what, maybe 3, maybe 2. Yeah, so that's looking pretty good. If I hit play, you'll see these traveling around, just passing right through each other. Feed that volume builder into a volume mesher, and now we see a final mesh. So now we get this fun blobby thing going on. It's running pretty quickly overall, but what I'd like to do is make this completely flat. What's a good way of doing that? Well, that's where I'm going to use our other plugin, which is Rocket Slicer. Here it is, unrelated plugin. That's a separate purchase. But if I make a slicer and I feed the volume mesher inside of it, you're going to see it's going to be cutting that mesh. And in this case, it's cutting it vertically. But what I would like to do is have that, I'll pull it out. I would like it to do a single cut along Z. So I'll say Z+, and I want to only do a single cut. And just because the text is perfectly at 0, I'll scoot this back just a hair. And now if I feed this volume mesher into the slicer, we get a single cut straight through it where those spheres have blobbed into that geometry of the text. So now that I've got this final shape, I could feed that into, let's say, another smooth. We'll feed it into a Rocket Smooth. It's going to round those out a bit. Maybe I would want to subdivide it by 1. So I'll say subdivide 1, add in just a little bit of rounding to take the sharp edge off anything where it might be. We've also got our minimum length, which I haven't talked about. As we add additional iterations of smoothing, everything naturally shrinks, as we've talked about. As a circle shrinks, it might disappear, and that's because we have a minimum length set. And the reason for that is if I add a lot of iterations, let me set minimum length to 0. As I add a lot of iterations, those are going to shrink down to essentially 0. Like they just become a tiny little point right there. And that might look weird on a render or if you're cloning onto it. So oftentimes, most times for me, I want to make that disappear if it gets too small. So in this case, I'll say if it gets smaller than a length of 1, then it will disappear. But otherwise, it gets to remain. So now that that's happened, I would probably like to reduce our points. If I double click, you see we got a lot of points around the entire thing. So I'll feed that into a, hold down Alt and create another reduction. And I'll set that to 0.1 again. So tolerance 0.1. Now we keep only the sharp areas, double click on it. You can see that I've gotten rid of tons of the points, looking pretty good. Let's drop that into this weighting extrude. And now you can see that we made a essentially flat 2-dimensional shape where all that stuff is blobbing into each other, just feeding into the text, blobbing back out again, getting smoothed out as it goes, and running relatively well considering how much resolution I put into that volume measure. I really like this workflow. I often find myself making some complex model and then using the slicer to cut it, and then Utility Spline just becomes so useful for bringing additional smoothing and detail and then reducing the point so that everything can run quickly in something like an extrude or a sweep. So yeah, that is that demo file. And again, it's included along with the example files. For the next demo file, let's start just from this spline. What I've got here is I found an image of a mirror and I brought it into Photoshop and I selected a bunch of it and converted it to paths, exported it to Illustrator. And this is a spline I get from here. I bet oftentimes you get a file like this from a client where it's pretty messy. It's not looking so good. If I click on points, you see it's incredibly subdivided. It looks really messy and they are going to want some sort of changes on it. And it's just going to be impossible to work from this. Well, let's use a series of utility splines to make this way more workable. Here's my thought. Let's feed this into the utility spline and I'll start with a reduction. By default, it's on deviation, but I'm going to change this over to optimize. Let's double click on it and take a look at what optimize does for us. What optimize is going to do is it finds a point and it starts walking along the spline and it says no point can exist until I've traveled at least 1 unit because we're set to 1. So if I say 5, it's going to go to a point and start going along until we've gone a distance of 5 and then find the first point after that and then do it again and again and again. So we've now reduced the points by just kind of walking along and only keeping the original points. Now, in this case, I don't want to get rid of too many, so via my test, I think 0.5 looks pretty good. You'll see that if I say a tolerance of 0, we've got tons of points. We're getting like this pixelated stepping, not looking so good. So if I say 0.5, now we end up with a way more controllable line. Not perfect yet, but definitely more controllable. We'll be using a couple of these, so I'll just rename this to .optimize. because now I'm going to feed this reduction into another reduction. In this case, I'll say Utility Splines Reduction. And this time, I think I do want a deviation. We've talked about this one a little bit, but you'll see that it is removing the most redundant of points. In this case, a tolerance of 1 might be good. Maybe we want a little more detail. Say 0.1. Yeah, it's working all right, where we've got the detail, but way more reasonable points, but we still got the curvature where we want it. So now, maybe that will be renamed dot deviation. This step wouldn't be strictly necessary, but I'm going to feed this into another utility spline. In this case, I will do a resample. And the reason I'm doing resample is I would like there to be a very even point count traveling around. So now as I double click, you can see that we've taken the previous results and now we've got something very clean and reduced. We are currently doing a step of 5, but there's actually an additional setting I'd like to use. So if we twirl this down, you'll see we got a couple extra settings, and one of them is retain. And currently we're not retaining any of the original points, but we can say, you know what? The other one was very reduced. Let's say we want to keep those points. And the reason for that is you'll see that we've got these kind of mushroom shaped details up here. And if we just do the simple step, you're going to see that it's getting rid of a lot of their detail. But if I say keep those original points, those came back again. And now we just are getting even subdivisions between where those used to be. So this puts us in a really good state. It's already looking way better and way more controllable, but we can make this super controllable with the last tool we haven't played with at all, and that is the Utility Splines Rocket Bezier. So if I hold down Alt, I can feed this into the final result, and if I double click on that icon, you're going to see that these tick marks look a little bit different, because what this is doing is converting the spline back into a Bezier spline, something that's way more controllable. So in this case, if I zoom up, you can see that we've got the tick mark for the point, and then the virtual handles of what the Bezier spline would be. Now we got a couple different settings here. They're a little bit more technical, but for the most part, you can just kind of wiggle the sliders around until you get something that you like the look of. First of all, we've got the tolerance, and the tolerance is super important for how many points we're going to end up with. If I were to decrease the tolerance, you're going to see that we're going to end up with more small Bezier handles. But if we increase the tolerance, then we're going to end up with fewer handles traveling around it. If I go and we go really far, I can start dragging this up and you can see we're going to get less and less and less until we're finally left with just like 2 points per blob, but it doesn't look like the original shape at all. So tinker around somewhere around 1, maybe 1.5. Yeah, there we go. That's looking really good, where we've got some handles making this way more controllable, but not so much that we're losing too much of the detail. Moving on, we've got a setting called Detect Corner, which can be pretty powerful. I'm going to grab break tangent and put it to 0 so we can explain it. Let's zoom up on those mushroom shapes. You can see if I say none, everything is getting rounded, everything. But this is trying to detect any sharp corners that there are. And if I were to turn off this Bezier, you're going to see that there's a perfectly straight line traveling from there to there. So that's what Detect Corner is doing. It's like, oh, one of those edges is perfectly straight. So if I turn that on, you see we get that nice sharp angle right there, and in a couple of other places as well. We can also say 2 edges. That's not going to help us here because that's trying to find 2 sharp edges that meet each other. But let's say 1. And then we've also got this break tangent. What that's going to do is try and find how sharp that angle is to the next angle. And if it's above this threshold, it's going to break the tangent. So I want to increase this until we kind of get this mushroom shape back nice and sharp. So if I find the right balance here, right around there, we got a sharp edge everywhere I want to, but like these big round parts of the mirror are very smooth looking. We got nice unbroken tangents. Now that I've done that, I can make this editable if I want to and go to point mode. And now you can see I've got some lovely Bezier handles I can work from. So let's open up the original file again and copy that spline and paste it in here. And let's take a look at the difference between the point count we were originally coming in with and how uncontrollable that was. And now let's click on this Bezier and look at these handles we've reduced this to make it very controllable. Now this is applicable in a lot of different places depending on what you're doing. Going back to that very original file here, if I were to grab that camera track here, let me hit S and zoom up on it. If I feed this into a lovely smooth and we smooth that out and counter scale, but let's say you need to edit this, like it'd be a pain to edit this line. But if I take the smoothed out track and feed that into a Bezier spline, you're going to see right away that I don't even see a difference. It didn't change at all. If I double click on here though, you see that we get these nice Bezier handles. If I, again, start increasing our tolerance, we can get fewer points that make it up. We can keep pushing it further and further. You eventually get to a point where it's not overly helpful. But if I make that editable now, I've now reduced this crazy super detailed spline into something that I could very easily manipulate, get exactly what I want, and continue on. So yeah, the Bezier spline is the only way I know of getting something back into the form of a Bezier. We put a lot of time into that one. It took a while. But in any case, we've got a final demo to take a look at here, and then we'll be all done. The last one is this file here. And this is another one. We're going to be using another different plugin from Rocket Lasso. Unrelated to this one is going to be the Mesh to Spline. If you have the Mesh to Spline plugin, I already have a demo in there all about converting this car from the asset browser into nothing but splines. You see, we got all these splines here making up a car. It makes it really fast to render in third-party renderers because there's not all that geometry and lighting. All you have to do is render the spline. In any case, it's all been converted already. You see, I got a bunch of different Mesh to Splines here. So I would like to, it's converted from polygons to splines. And as a car, you'll see that the Mesh to Spline converted. Let me show you. Unhide all that. We've got all that geometry, and I've converted it parametrically to outlines and converting the entire mesh and certain thresholds and certain angles. Everything's been converted over into a spline here. And you can see that it's running nice and quick. But now that these are splines, if I zoom up, you see that they start looking a little bit chunky here, like these angles, like right there, pretty sharp along these headlights. Maybe I want that to look a little bit better, a little bit smoother. Like these curves just aren't quite doing it for me if those were going to get rendered. So let's go and create a utility smooth. And I don't want to put the tires in there, but I'm going to grab all these other ones. And this is pretty cool. If I drag all of these and drop them as a child of the smooth, you're going to see that they all get the smoothing applied. It can be fed multiple splines. Doesn't look too great out of the box though. So what do we want to do? Well, let's get rid of all these iterations to start with. And just like we've seen before, we're feeding in a very low point count. And if there's very few points, smoothing goes a really long way. So I think we need to subdivide this a bunch and then smooth it. So I'll zoom up on that headlight again. Right here is where it's looking, it really stands out to me where it's really kind of chunky. So how about we subdivide? My favorite way of doing this, I'll say, hey, anywhere that needs more resolution can just be subdivided. So I'll say a subdivision of 1. If I double click on it, you'll see that we get all of our tick marks. I can say, nope, subdivide again. And then I'll turn off our tick marks if I double click. Actually, something important here. I just subdivided and subdivided again. Now you see that there's an X on our icon. It's grayed out and there's a little X, and you'll see inside the tool, we're getting a warning, exceeded point count. We have under advanced a built-in point cap, just in case you drop something in or you change a number and it would be, creating an insane subdivision. Well, this stops you from freezing up Cinema because it's going to be calculating forever. So there's a point cap limiting you. When you exceed the point cap, we got 2 different ways of getting around this. Well, 3, I guess. You can increase your point cap, or you can click the override button, or even better, if you see this icon with a little X, if you're confident, you can just double click on the icon. It's the same as pushing the override button. What that will do is automatically calculate how many points there would be, and it sets your point cap to that amount. So it's not going to make a giant, huge number. It goes to the exact amount you need if you're confident you can subdivide that much. In any case, I can double click again, hide those tick marks. But now that we subdivided 2 additional times, there's a whole bunch more points here, meaning I can start adding in iterations, and you can see that those are now smoothing out and looking nice and clean. Way more detail for that. As soon as I zoom out, you see lots of detail there to render without losing the overall silhouette of the car. Working great. As we've talked about, we create a lot more points here. In fact, if I click on the smooth and go to advanced, you'll see that we went from 35,000 points up to 115,000 points. So that's a lot of additional points. So it's times 2 times 2. What if we reduce those down again? I will select the smooth, hold down Alt as I create a reduction. And as usual, I will, and the point count is exceeded there. I'll double click on that as well. I would like the tolerance to be 0.1 again, my favorite number on there. And that's going to remove all the points we don't need. So if I double click again, you'll see we have lots of, let me rotate around so we can see it in silhouette. Lots of detail here in the curve, but fewer on these straight areas. So that's working great. Zoom out. But I want to call attention to a couple other things, even though that works really well with Ricochet and Slicer and Mesh to Spline and any other splines that you generate, including tracers and any of the primitives or text splines, anything works well with those. I love the way it combines with our own tools. It combines really well when you're playing with the rope simulation stuff. Another detail I want to mention here before we wrap up is every one of the utility splines Well, first of all, you can change the utility very quickly. If you have one and you're like, well, I don't want it to be cleanup, I want it to be smooth, you can just switch the mode here. We made it so they're all swappable. But in addition to that, I want to move into the spline tab. Now, when I have the spline selected, you see everything is highlighting in orange. I don't want to do that. So I will lock this and deselect it. So that way we're actually seeing the colors here, because that's what I want to talk about. Currently, we are feeding in, you'll see 6 different splines are being fed in. Not only that, each of those splines have a bunch of different segments involved in them. But you'll see if I make this reduction editable, that it's exploded, and now we've got all those individual splines there, and they've, let me unlock. You'll see that they've been given the appropriate color. So it was able to maintain that and work for multiple objects. Hitting undo, bring this back, and locking again. In the spline tab, currently it is seeing the segments however we feed them in. But I could say, actually merge them all into one. So now they've all been merged into a single spline. It's just returned them to the default color, and because one spline was closed, they've all become closed. Depending on what you're doing, it could be a good idea that you want to merge everything down. In this particular scene file, you probably don't want to do that. In addition to saying as input, we could also say explode all. So every single segment, every little individual segment has exploded into a separate object, meaning when I make this editable and I open it up, we're going to get every single spline segment as its own object, but it was given the appropriate name, and if I unlock, it was also given the appropriate color. So it is maintained. Undo. Okay, back here again, lock. But there's some pretty cool things you can do in addition to that. If we say, I'll go back to single, or I'm sorry, as input, so we're seeing the 6 different objects. We've got a colorize set up here, and currently it's as input. Whatever the color was when it comes in is the color we're going to see here. But I can say, actually, I would like to see a random color. And now every object has been given a random color based on the seed. And click random and get all these crazy different random colors. It's kind of fun to go through here and try and find a nice one. I kind of like this one. That looks neat. So let's say I want to render that out. Well, we can set this to redshift. So say cinema redshift, and then add in a render redshift object. And let's say I would like to see these as, unlock, got to remember that. I would like to see these as a hair strand. And currently the thickness is pretty thick, so I'll set that to 0.5. So if I hit render, Control or Command R, you'll see that nothing happens. Why aren't we seeing anything here? Well, there's a very good reason for that, and that is the redshift tag. I'm not sure if this is for every third-party renderer, but it doesn't automatically apply to children, only the object it's directly applied to. So we actually compensated for that as well. I can click on our reduction, and you'll see that there's a tag to splines setting. So if I drag that tag in, it is now going to get filtered down to all the children. And just to show you, if I make that editable, you'll see that every child is now given the tag. Otherwise, it wouldn't be. So now that that tag is being filtered down, now if I hit Control or Command R, we should see that we instantly get a, we've got all the splines rendering directly in Redshift. And those render nice and quick because there's not much in the way of lighting and like just nice, simple, clean splines. You actually push that a little bit further. If I click on the reduction, I could say, maybe not random color, but grayscale. Let's, again, lock so I can see the colors. Now we get random grayscale colors, anywhere from black to white, randomly getting applied on the car. But let's switch that back to random color. And now I'll say I would like the segments to be explode all. And now every single different segment is being given its own random color, randomizing around, getting whichever color I want, or even you could keyframe your seed here and have those be animated. Hit render, and now you'll see that every one of those randomly colorized segments is going to be filtered through and rendered directly. The wheels are not, because I didn't copy the tag manually over onto those. And now you'll see that those wheels will also render. So yeah, lots of fun to be able to combine these with your third-party renderers and with Redshift and get those combinations, the ability to keep things parametric, but explode out segments or colorize them. I find it very helpful to be able to colorize them with the black and white with the grayscale, and then you can bring those into the nodes and say, remap those onto like particular rainbow colors. Important to note as well that we can turn on enable and change the tessellation of the splines that we're seeing. We could say, actually, you're going to be a B-spline or a uniform or subdivided. So you can change that parametrically without having to worry about it. You can also reverse your spline. But in any case, that's going to wrap up all of these demos. I suppose really quickly, I'm going to pop open every one of the example scene files. When you download your copy of Utility Splines, you're going to have this folder with like the instruction videos and whatnot, but you'll have this example files folder. And inside there, we've got a bunch of different examples. So I'll pop them open. First of all, you get, yes, you get this demo file I started out with. We've got that lovely wiggly spline text. You can hit play and see that wiggling around. Some simple smooth text. Here's an example that probably nobody's ever used. This text is set to GG font, which I'd love to know if anybody's ever used that before. But if you drop that into the smooth and put the right settings there, you can actually make it into something that's kind of usable and nice looking. Definitely for a smoothie shop, I think. Then we can open up this random fill shape. If I hit play, it's very much like that ramen noodle setup where it's just filling up a nice shape. And then I think I have the actual ramen noodle scene file already all set to go. So you can just hit play and see pretty much the exact same thing I demoed for you. After that, I've got, this crazy world map. So I got this, it was originally Ricochet. I made it editable, and now I'm running the rope simulation on there. So if I hit play, you're going to see that the rope simulation is going to have me drifting around just via a noise cloud. But then if you want to go extra far, I can clone and blend between two different smooths, and you're going to end up with this crazy looking thing here. So when I hit play, you see it's going to run really well, and we get these splines that are getting mapped and blending between the colors and how smooth they are. So you get some crazy looks there. Just fun, weird, experimental things. Here's that mirror file that I showed you. Now, if you actually take that final mirror spline that I had put together there, you can actually layer it up a bunch of times into a volume builder, and you end up with a nice piece of geometry here that actually make a fancy looking mirror pretty easily. Then we've got that car file already in its final state, ready to be used. Here's Scribble Man. I'm not going to spend too much time on this one, but I've got a character that was filled up with this bouncing line, made editable, and then I actually mapped it. I did the character binding to it, so that is going to animate as a character. So then I can resample it and smooth it and add that jitter back in, and now we can get a cool little scribble guy. A similar but different setup here. This is also using a jiggle deformer. As you can see that the hand's going to go all crazy, but being able to modify that spline and get a crazy looking character. Lots of different possibilities there. Here is a little lightning rig set up by using a tracer line. And you can see here that if I move this line around, I'm able to create this cool looking electricity here with some noise deforming things and getting smoothed out and then resampled and deformed again. So that layers up really nicely. Simple setup here where I'm exploding some parametric text by exploding them and randomizing the colors. So you get different colorizing. And then we've got this file, which we completely stepped through. So here's a final version. We hit play, let these drift around, blobbing, doing their thing. Something that I did accidentally that looked kind of cool is if I pull the text spline out, yeah, I think it looks pretty cool that way as well. So without extruding that, we can still get this shape. Pretty neat. And then finally, this one, I need to open up 23.1 because I'm going to be using Pyro in this file, and it does say in the file that you need it. So what you will be seeing on this one, let me turn a bunch of stuff off and show you that we are generating Pyro, but that's being fed into a volume mesher. So we get a giant puff of fire and smoke essentially, but I turned it into geometry. But then I say, actually, I would like to slice it with Slicer. So we end up, and I'll hide that again, we end up with a cross section of it. So if I hit play, we get that lovely cross section going. But then I can say, take that end result and subdivide and smooth it to round out those corners. Using utility splines, we could clean it up with a reduction, but in this case, we just feed that into a loft. We get this flat cross section of it traveling upward, which I think looks pretty cool. Get a two-dimensional smoke or fire. And then you can feed this into a cloner and get a bunch. This is literally a new slice per cloner. So you actually get a lovely cross section of the entire thing. Let's do a count of 7 on this radial, and you can see we get the overall shape of what the smoke and fire would be doing, but via a series of slices and smoothing. So that is all of, I think, 15 different files I'm including on these examples. So that will wrap this up. Remember, go check out the instructional videos talking about every single individual tool. That's really important to see exactly what every single parameter does. There's tons of things I didn't talk about, like distance iterations and neighbors and point caps. I go over every single little setting. I mean, we've even got like fields you can use in here. So there's a ton of additional things that this can do on a technical level. And as you watch my live streams and future tutorials, I'm sure you're going to be seeing me use the utility splines all the time because they're just so useful all over the place. I know they're not as flashy as a couple of our other plugins, but just for pure utility, like these are amazing. So thank you so much for supporting Rocket Lasso and purchasing the utility splines, and I'll see you in the next live stream or tutorial. Bye-bye, everybody.